second section in Chapter 9 is about translations. So by the end of this lesson, you should be able to identify and draw translations. Remember that isometry is a transformation that does not change the shape or the size of the figure. So all of the things that we're going to be drawing are congruent to the ones that we started with. So reflections we did yesterday, flipping something across the line. Today we're going to cover translations, which is sliding something across a vector. So that's why we talked about vectors in Chapter 6, because we're going to use them again today. So tell whether each transformation appears to be a translation, and then explain. So basically what you're looking for here is, could I take the blue thing and slide it somewhere? Not picking it up, not turning it at all, just moving it left, right, up, down, and get the next figure. And this first one would definitely be a no. It's a reflection. If I fold my paper right there, you get the same thing on both sides. But this one here, if I take this blue thing and slide each of these points in the same direction and the same distance, we end up with the red thing, or we could have started the other way around. So a translation is a transformation along a vector such that each segment joining a point and its image have the same length as the vector and is parallel to the vector. So I'm going to take this point, point A, and move it the same distance here as this vector and parallel to that vector, and that's how I get my image. So in a coordinate plane, in order to transfer something horizontally, all you have to do is add that horizontal motion to the x value in your point, because remember, x moves left and right. To translate something vertically, all you got to do is add something to the y value of your point, because remember, y moves up and down. And then to translate something along any vector, you take whatever the vector is, a, b, and you just add that. You add the a to your x and the b to your y, and you're done. So basically the rule of thumb is take whatever your vector is, and that's how you shift your stuff. So translate the triangle with vertices D, E, F along the vector 3, negative 1. So let's plot D, E, F. E is at 5, negative 3, and F is at negative 2, negative 2. It's kind of a skinny, very obtuse triangle. And this vector right here, 3, negative 1, tells me that I'm going to go right 3, because that's the x direction, and down 1, because that's the y direction. So everything gets moved. So if we want to make our points, D prime is going to be at negative 3, so you add 3, and you subtract 1. So it's going to be at 0, negative 2. So 0, negative 2, let's get a different color. There's D prime. E prime, again, you add and add, so you're adding a negative 1. That turns into 8, negative 4. So that's going to be way off the paper here. And then F prime is negative, add 3, add a negative 1. So negative 2 plus 3 gives us a positive 1 and a negative 3. So positive 1, negative 3. And then we know the E is way off of here, going off of our paper. Let's do another. Translate this quadrilateral with vertices of R, S, T, and U along the vector of negative 3, 3. So this tells us that we're going to take everything and we're going to move it left 3 and then down 3. So our first one is at 2, 5. There's R. S is at 0, 2. T is at 1, negative 1. And U is at 3, 1. So here's our quadrilateral, four-sided figure. And every single point, we're just going to move left 3 and down 3. So 1, 2, 3, 1, 2, 3. This is where R prime needs to be. And again, we could find the points by counting like this, or we could just subtract 3 subtract 3, so you have it at -1, 2, and that's where our point is. And then S, I'm going to do the same thing, go left 1, 2, 3, down 1, 2, 3. This is where S prime has to be. T, 1, 2, 3, 1, 2, 3, T prime's got to be right here. Then U. So it looks like this shape wasn't changed at all, everything just shifted. And we could draw that vector of 3, -3, and all of these points should have the same vector there. So let's try a problem like this. A rook on a chessboard has coordinates of 3, 4. The rook is moved up 2 spaces, then it's moved 3 spaces to the left. What is its final position? So if we start with this point 3, 4, the first thing that they're asking us to do is move it up 2 spaces. Up and down, remember, affects the y values. So we're going to take our y value and we're going to move it up 2. So we're going to add 2. So by going up 2 spaces, we're moving this thing from 3, 4 to 3, 6. And then they ask us to move it 3 spaces to the left. Now that affects our x values. And if we want to move left, that's kind of like backwards. So we're going to take our x and subtract 3. So left 3 is going to put it at 0, 6. So if we want to write a vector that gets us from here to here, stop and think about what that means for your x's and your y's. So if you start at 3 and you have to get to 0, you need to go backwards 3. If you start at 4 and you need to get to 6, you need to go up 2. And then if you drew yourself a little picture of this, you first start at 3, 4. So over 3, up 4. And then you move to over 0, up 6. So our vector shows that we went backwards 3 on the x-axis and then positive 2 up. So even though that wasn't the order that they gave it to us, that's the order we have to put our vector in. So you should be able to identify and draw translations. Write down any questions you have and we can go over them in class tomorrow. Enjoy your night.